Introduction. Dear students, acid, bases and salts are three distinct classes in which almost all organic and inorganic compounds are classified. A famous Muslim chemist, Jabir bin Hayyan, prepared nitric acid, hydrochloric acid and sulphuric acid. In 1787, Lavoisier named binary compounds of oxygen such as carbon dioxide and sulfur dioxide as acids. Later on, in 1815, Sir Humphrey He discovered that there are certain acids which are without oxygen, like hydrochloric acid. He also proved the presence of hydrogen as a main constituent of all the acids. It was also discovered that all the water-soluble metallic oxide turn red litmus blue, which is a characteristic of a base. So this small introduction is about acids and how different scientists contribute and prepared different acids. Now here are some important properties of acids. The word acid is derived from the Latin word acidus, meaning sour. Acids have sour taste, they turn blue litmus paper red, they are corrosive in concentrated form. As you all people know that concentrated form in which there is more amount of solute and less amount of solvent. The aqueous solution of acids can also conduct electricity. As we all people know that there is a little concentration of hydrochloric acid in our stomach as well, which help us to break the food. Sometimes if the concentration of that stomach acid becomes too much, which causes an acidity, or we call a condition heartburn. This uncomfortable feeling is easily treated by taking an alkaline medicine like a base medicine. This alkali medicine neutralizes the effect of acid produced in the stomach and produced a harmless chemical which is called a salt. Properties of bases. Bases have bitter taste as compared to acids and they feel slippery. If you touch a base, you will feel slippery, like the sensation or the feeling when you touch a soap, you feel yourself slippery on your skin. This is due to the presence of a base in the soap, like sodium hydroxide is used in the manufacture of soap. Bases turn red litmus paper blue. The bases are non-corrosive in nature. Like we have discussed in our previous slide, acids are the aqueous solutions of acids conduct electricity. Same bases aqueous solution can also conduct electricity. Bases are non-corrosive except in concentrated form of sodium hydroxide and potassium hydroxide. If both these bases are in their concentrated form, they are corrosive in nature. Otherwise, bases are not corrosive. Arrhenius concepts of acids and bases. According to Arrhenius concept, acid is a substance which dissociate in aqueous solution to give hydrogen ion. As you can take a reference from your book, page number 21, there they have shown you a general ionization of acids that takes place. Dear students, ionization is a process in which a substance is converted or break down into ions. When the acids break down into ion, it produces positive hydrogen ion and a negative ion. There are so many compounds which splits or dissociate themselves and producing hydrogen ion, such as hydrochloric acid, nitric acid, acetic acid and hydrogen cyanide. They ionizes in aqueous solution to provide hydrogen ion. One more thing to remember, that aqueous solution is very much important. Aqueous means the presence of water. The ionization of a substance takes place in the presence of water. Basically, Arrhenius concepts shows that if a substance breaks, it breaks or dissociate in presence of water. According to Arrhenius concept of a base is a substance which dissociates in aqueous solution to give hydroxide ion. The journal ionization of base takes place, and you can see in book page number 22. The substances such as sodium hydroxide, potassium hydroxide are bases because these compounds ionizes in aqueous solution and provide hydroxide ion. So dear students, if we summarize the concept of Arrhenius, acids give hydrogen ion in water while bases give hydroxyl ion in water. Dear students, as we have discussed the Arrhenius concepts of acid and bases, now there are certain limitations of this concept as well. As we have discussed earlier that according to Arrhenius concepts, aqueous medium is very much needed for the ionization of a compound, either it is an acid or a base. So in this way, this concept is only applicable in aqueous medium and do not explain the nature of acids and bases in non-aqueous medium. If there is non-aqueous medium, then how can we differentiate between an acid or a base? Number 2 limitation is this. According to this concept, acid and bases are only those compounds which contain hydrogen and hydroxide ion. Let's suppose if we were having a compound that do not contain any hydrogen and hydroxyl ion, how can we tell the nature of that compound? Either it is an acid or a base. So here is a limitation of Arrhenius concept as well. These concepts cannot explain the nature of compound like carbon dioxide and ammonia, which are acid and a base respectively. So dear students, this concept has limited scope, yet it led to the development of more general theories of acid and bases behavior. I hope this lecture will help you in understanding the concept of acid and base. If you were having any problem, any ambiguity, we will discuss this in our meetup class. Stay blessed. Thank you very much.
So let's start our topic. Today we were going to discuss the physical properties and the chemical properties of acids. As we have discussed the physical properties of acids in our previous slides, now we will discuss the chemical properties of acids. The first one chemical property of acid is with metals. Acids react explosively with metals like sodium, potassium and calcium. However, dilute acids react moderately with reactive metals like magnesium, zinc, iron and aluminium to form their respective salts with the evolution of hydrogen gas. As you can see in this reaction, when the zinc react with sulphuric acid, it will produce zinc sulfate and hydrogen gas. This hydrogen gas, here is an arrow over there which represents the liberation, the formation of a gas. Number 2 chemical property of metal is reaction with carbonate and bicarbonates. Acids react with carbonates and bicarbonates to form the corresponding salts with the evolution of carbon dioxide gas. Here they have given you the reaction of calcium carbonate with hydrochloric acid. As a result of this reaction, this calcium chloride is formed along with the liberation of carbon dioxide and water. Reaction with bases. As you know that whenever the acids react with a base, that will produce a salt and water. And this whole process is called a neutralization reaction. So in this case, when the acids react with bases, major bases are oxides and hydroxides of metals and ammonium hydroxide that will form a salt and water. As you can see in this below reaction, that sodium hydroxide when react with HCl, that is an acid, it will produce a salt which is called a common salt, sodium chloride, along with water. Reaction with sulfides and bisulfides. Acids react with sulfides and bisulfides to form the salt with the liberation of sulfur dioxide gas. When the calcium sulfate react with hydrochloric acid, it will produce calcium chloride, sulfur dioxide gas, and water. The last chemical reaction of acid is reaction with sulfides. Acids react with metal sulfide to liberate the hydrogen sulfide gas. Here they have given you an example. When iron sulfide react with sulphuric acid, it will form iron sulfate as well as hydrogen sulfide gas. Now here are some uses of acids, the acids which we are used in our daily life. Sulphuric acid. Sulphuric acid is used to manufacture the fertilizers ammonium sulfate, calcium superphosphate, explosive, paints, dyes, drugs. It is also used as an electrolyte in lead storage battery. As it is a good conductor, that is why it is used in lead storage batteries. Nitric acid is used in manufacturing of fertilizer like ammonium nitrate, explosive, paints, dyes, drugs, and etching designs on copper plates. Hydrochloric acid is used for cleaning the metals, tanning, and in printing industries. The process tanning is it's a process in which the skin or the hide of the animal is being processed to convert them into leather. Benzoic acid is used for the food preservation. It is used as a preservative to preserve the food in order to protect the food from the different bacteria or from the putrefaction of the food. Acetic acid. This acetic acid is very much known to all you people, that is a vinegar. This vinegar is used as a flavoring for food and as a food preservative. It is also used to cure the sting of wasp. G. Moving on to our next properties, that is the general properties of bases. Physical properties. As we have been discussed the physical properties of bases as well and in our previous slides. So here are some chemical properties of bases. So number one, reaction of base is with acids. Yes, as we have discussed in our previous slides as well, when the acid reacts with a base or when the base reacts with an acid, they will produce a salt, which is a harmless thing, and it will also produce the water. And this whole process, the reaction between acids and bases, is called a neutralization reaction. As you can see below, they have given you a base that is react with an acid and it will produce a salt as well as water. Reaction of bases with ammonium salts. Alkalis react with ammonium salts to liberate the ammonia gas. This alkali react with sodium hydroxide and it will produce a salt, that is sodium chloride, ammonia gas, and water, as you can see in the below reaction. Precipitation of hydroxide. Alkalis bases precipitate insoluble hydroxide when added to solutions of salt of heavy metals such as copper, iron, zinc, lead, and calcium. Yes, whenever a base is react with the copper salt, iron salt, and the zinc salt, they will produce the distinguished color which help them to differentiate between different colors. As you can see in the examples below, that when the copper sulfate react with sodium hydroxide, it will produces the blue precipitate. When the zinc chloride react with the sodium hydroxide, they will produce white precipitate. Similarly, when the iron chloride react with sodium hydroxide, it will produces brown precipitate. When the lead when the lead react with that sodium hydroxide, it will produce the white precipitate. Calcium chloride react with the base, it will produces white precipitate, and when the iron sulfate react with sodium hydroxide, it will produces dirty green color. So according to these color, we can differentiate between different precipitates of hydroxides. Now the uses of bases. Sodium hydroxide is used for the manufacturing of soap. Calcium hydroxide is used for the manufacturing of bleaching powder, softening of hard water, and neutralizing acidic soil and lakes due to the acid rain. Yes, this calcium hydroxide is used to neutralize the effect of acid in the lakes and the soil, because when the acid react with the base, it will produces a neutralization reaction and produce a neutral substance. Potassium hydroxide is used in alkaline batteries. Magnesium hydroxide is used as a base to neutralize the acidity in stomach. It is also used for the treatment of bee sting. Yes, you people have familiar with that Gaviscon syrup, mucane syrup, and that the medicine which we use to relieve from that stomach acidity. Whenever we'll feel stomach acidity, we use these type of medicine. So these type of medicines contain the basic medicine in them, which will neutralize the effect of stomach acidity. Aluminium hydroxide is used as a foaming agent in fire extinguishers. Ammonium hydroxide is used to remove the grease stains from the cloths. Stomach acidity. Stomach secretes the chemical in a regular way to digest the food. These chemicals mainly consist of hydrochloric acid along with an other salt. Although hydrochloric acid is highly corrosive, but the stomach protected from its effect because it is lined with cells that produce a base. Yes, our stomach lining helps our stomach to protect it from its hydrochloric acid. The base neutralizes the stomach acid. The important function of this hydrochloric acid is to break down the chemical bond of the food in the digestion process. Thus, the big molecules of the foods are converted into small ones. It also kills the harmful bacteria of certain foods and drinks. However, sometimes when the stomach produces too much acid, it causes the stomach acidity, which we called hyperacidity. Symptoms of this disease are feeling burning sensation throughout the gastrointestinal tract. These feelings sometimes extended toward the chest. That is called the heartburning. So, my question is here, how can we treat this stomach acidity? Yes, if we can avoid that spicy food, we can avoid the fatty acid food, then we can definitely relieve from that stomach acidity. Simple and regular eating, remaining in an upright position for about 45 minutes after taking a meal. Keeping the head elevated while sleeping. So there will be a no backflush of the food in our gastrointestine, in our esophagus. That's why we'll have to keep the head elevated while sleeping. So stomach acidity can also be relieved by using a medicine which is basic in nature, so that the stomach acidity can be neutralized by using a base. I hope that this lesson helps you in understanding all the above topics mentioned. If you were having any problem, any ambiguity, we will discuss inshallah in our meetup class. Stay blessed, stay at home. Thank you very much. Allah Hafiz. Salts. Salts are ionic compounds generally formed by the neutralization of an acid with a base. Salts are made up of positive ions, that are cations, and negative ions, anions. A cation is metallic and is derived from a base. Therefore, it is called a basic radical, while an anion is derived from acid. Therefore, it is called acidic radical. As we have discussed in our previous slides about the neutralization reaction, so same the salts are produced by the combination of an acid and a base. Dear all, A salt gets its name from the names of the metal and the acid. As you can see in this table 10.4 that is present on our book page number 38, they have given you a table of metal, acid and the salt name. In this, the metal sodium reacts with hydrochloric acid and form a salt that is sodium chloride. Potassium reacts with nitric acid and form potassium nitrate salt. Similarly, zinc reacts with sulphuric acid and form zinc sulfate. Calcium react with phosphoric acid and form calcium phosphate. Silver react with acetic acid and form silver acetate. Now, the characteristic properties of salts. Salts are ionic compound formed in crystalline form. They have high melting and boiling point. Most of the salts contain the water of crystallization, which is responsible for the shape of crystals. Number of molecules of water are specific for each salt and they are written with the chemical formula of salt. As you can see in this example given below, copper sulfate along with the 5 molecules of water. Yes, so these salts were having the water of crystallization. How many molecules of water are there in copper sulfate? So there are 5 molecules of water. Similarly, calcium phosphate is also having that 2 molecules of water. Number 4th property is salts are neutral. Yes, as the salts are ionic compounds and ionic compounds are formed by the positive and negative ion, so the salts are generally neutral compound. Although it doesn't mean that they do not compose of equal number of positive and negative ion. It doesn't mean if positive ions, let's take an example, if positive ions are 10 and negative ions should be 10. No, it's not like that. Fine, but they have the equal number of positive and negative charge. It means the strength of positive and negative charges are equal. That nullifies the effect of each other, and that is why the salt is neutral. Now here comes the preparation of salts. Salts may be water soluble or insoluble. The methods used for the preparation of salts are based on their solubility in water. Journal method for the preparation of salts. So there are different 5 journal methods for the preparation of salts. 4 methods make soluble salts, but 1 prepare the insoluble salt. So here we'll discuss one by one in this slide. The preparation of soluble salts. Soluble salts are often prepared in water. Therefore, they are recovered by evaporation or crystallization. So the soluble means it indicates that they are easily dissolvable in water. By the reaction of an acid and a metal, which is a direct displacement method. Yes, this is a direct displacement method in which hydrogen ion of an acid is replaced by a reactive metal. That reactive metal can be calcium, magnesium, zinc and iron. As you can see in this given below example, hydrochloric acid react with magnesium and form magnesium chloride along with hydrogen gas. By the reaction of an acid and a base, yes, you all people were very familiar with this neutralization reaction in which an acid reacts with a base and produce a salt. So they have given you an example of hydrochloric acid and sodium hydroxide, and they will react with each other and form sodium chloride and water. By the reaction of an acid and metallic oxide. Mostly the insoluble metallic oxides react with dilute acid to form the salt and water. And here they have given you an example of copper oxide that react with sulphuric acid and form copper sulfate and water. Yes. In your book page number 40, they have also given you another method for the preparation of soluble salt, that is by reaction of acid and a carbonate. Dilute acids react with metallic carbonate to produce a salt, water and carbon dioxide gas, as you can see in that below example. Now the preparation of insoluble salts. How the insoluble salts are prepared. In this method, usually the solution of 2 soluble salts are mixed. During the reaction, exchange of ion radical take place. In this, the metallic radicals exchange with an acid radical take place. Yes, the metallic ions will be replaced by the acidic ions. to produce the two new salt. One of the salt which is produced is insoluble and the other is soluble. The insoluble salts precipitates that is solidified in the solution, and we can easily separate the insoluble salt from the soluble salt. Like silver nitrate, when react with sodium chloride, it will form silver chloride as well as sodium. After the preparation of the salts, here comes the types of salt. So there are main classes for the salts are normal salts, basic salts, mixed salts, acidic salts, double salts, and complex salt. Number 1 is normal or neutral salt. A salt formed by the total replacement of ionizable hydrogen ion of an acid by a positive metal ion is called a normal salt or a neutral salt. These salts are neutral to litmus paper, that is, they do not give any color to the litmus paper. They have given you an example over there, like when hydrochloric acid is react with potassium hydroxide, it will form the potassium chloride and water. And another example they have given you, when these salts react with the metallic oxides, they will produce the neutral or normal salts. Acidic salt. These salts are formed by the partial replacement of a replaceable hydrogen ion of an acid by a positive metal ion. Here they have given you an example of sulphuric acid. When react with potassium hydroxide, it will produce the potassium hydrogen sulfate as well as water. These acidic salts turn the blue litmus paper red. Basic salt. Basic salts are formed by the incomplete neutralization of polyhydroxy base by an acid. This polyhydroxy base mean, as you can see in the below example, aluminium hydroxide when react with hydrochloric acid. This aluminium hydroxide is having the 3 hydroxyl group attached with it. So that is why it is called a polyhydroxy base. Mixed salt. Mixed salts contain more than one basic or acidic radical. Bleaching powder is an example of mixed salt. Now the double salt. Double salts are formed by the two normal salts when they are crystallized from a mixture of equimolar saturated solution. The individual salts component retain their properties. The anion and cation give their respective test. Mohr's salt, they have given you this formula, potash alum, ferric alum are the examples of double salts. Dear students, the formulas of these salts are very important, and from board point of view, they will give you the name of these salts and you have to write the chemical formula of these salts. Complex salts. Complex salts on dissociation provides a simple cation and a complex anion or vice versa. Only the simple ions yield the characteristic test for cation or anion. For example, potassium ferrocyanide gives an ionization, a simple cation and a complex anion. I hope that this lesson helps you in understanding the above mentioned all the topics. If you were having any ambiguity, any problem, we will discuss inshallah in our meetup class. Take care of yourself and